That's perfect. Thank you very much for leading me right into that. That was really great. Okay, so here's what we're going to do now. You can erase your boards. I just don't want to forget anything. And today, we're going to be learning about the partial products method. Partial quotients, I'm sorry. Sorry. And I'm just going to write partial quotients on the board, then I'm going to move over to there. But I want you to think about partial quotients. And while I'm moving, I want you to talk to your partner and say, what does partial quotients mean? And how does it relate to what we've done before with partial products? Okay? So just take a minute to talk to your elbow partner while I move to turn on my computer because I was... What does partial quotients mean?
Partial quotients is like, you know how we did division where it's just like 3 divided by 39 again. Well, 39 divided by 3. And then what we did, no, we did this in multiplication. Okay. With 2 digits, like 24 times 32.
Okay, we ready? I listened to what some of you were saying, and I saw some of you even writing out some multiplication problems to sort of put the two ideas together. Does anybody want to share what they were saying? I'd like to hear one group share what they were saying about partial quotients and partial products. And do you see any similarities there? Do you see how these can relate to one another? What do you think? Ben?
Well, partial products and partial quotients. The partial quotients, you're getting like fractions of the quotient because you're not getting the full quotient yet, but at the end you would probably like add them all up.
You would. And I like how you said fractions because fractions are parts, okay? So when you're finding the partial quotients, you're finding part of the quotient at a time, right? But at the end, you're going to add them up. Do you remember ever doing that before when you were using partial products? What did you do when you were doing partial products? Do you guys remember that? Megan, what did we do when we were doing partial products?
We did this thing called bow tie, and then it would be like, instead of in the tens place, like 3 times 4, if you were doing 24 times 32, like 3 times 4, it would be 30 times 4, which is 120, and then you would go down.
Do you hear what she's saying?
Up all of the...
Megan is also describing the standard algorithm for multiplication. But even with that, you are finding part of the product, but at the end, you have to add them together. So we're going to do the same kind of thing today with the partial quotients. Okay, so I want you to consider this problem. Here's a problem. My picture? At camp, there are 5 players on each lacrosse team. Okay, so you're going to camp, and there are 5 players in each lacrosse team. If there are 125 lacrosse players, how many teams will there be? And if you notice, I've already given you the problem that we're going to be solving together. But when we use partial quotients method, multiples of the divisor, and that's why you really have to know what your divisor is. What's your divisor? Everybody together?
125.
5. Divisor's 5. Multiples of the divisor are subtracted, notice these words that I have in bold, from the dividend. What's the dividend? 125. And then the partial quotients are added together. So let's do a little demonstration of how the partial quotients work. I'm just going to show you what I would do, and I'll talk through this, okay? So multiples of a divisor. So I'm going to make this line. Ooh, I hope this works. So I don't like the smartboard. I'm going to think of multiples of 5. Well, there's a lot of 5s in 125, right? And do you remember when we did the repeated subtraction, we could take away 5, and we can keep doing that, right? Remember we did that with the smaller numbers? Do we want to do it this way?
No.
Why don't we want to do it this way? Remember I talked about the grocery bags? Why don't we want to do it this way? Kobe?
Because it would take a long time to go all the way down to 0.
It would take a long time. It's not very efficient, right? So we really need to know how many 5s are there in 125. So we're going to think, I'm going to do this one, and I'm going to do it not the way I might do it right away if I really knew it well, but if I were just doing this for the first time, I would think, I'm looking at 125, and I'm thinking of 100, and I'm thinking of 25. So I'm thinking, 5 times something equals 100, doesn't it? Right? So I'm thinking there's at least 20 5s in 125, aren't there? Yeah. So if I took out 20 of those 5s, then I would use up 100. And what would I be left with? What would I be left with? Mia?
25.
25. So, oh boy. Now I'm thinking, how many 5s can I get from 25? And this should pop right out at you. How many 5s can I get from 25? Can you show me on your fingers how many 5s I can get from 25? Can you show me on your fingers? Good, 5 5s. So 5 5s, I'll use up 25, and I'll have none left. Anybody want to tell me what my quotient is? Do I have my quotient? Well, I have a part of it. Multiples of the divisor. Multiples of the divisor, 125, are subtracted from the dividend, and then the partial quotients are added together. So what do I have to do now? What do I have to do now? Victoria?
Add
Oh, sorry.
the 25.
Add the 20 and the 5, and I get 25. Now, I just like to show you how we can show it in a model like we did with the 39 and 3. So we know 5, right? And we know what's inside. We know 100. I'm going to do it like this. I'm going to do it like this. I'm going to break it up this way because that's easy. So what are we looking for? We're looking for these two factors. So we would put the 20 here because 5 times 20 equals 100. Look familiar? And 5 times 5 equals 25. I just broke it up that way. Two different ways you can look at it. Okay, this reminds me of the distributive property too, isn't it? Doesn't it? But I didn't break it up 100 plus 20 plus 5. But can I do that? Could I do 100 plus 20 plus 5?
Yes.
I could. Why? Why can't I do 100 plus 20 plus 5? I can. Why could I do 100 plus 20 plus 5? I don't have to do 125. I could do 100 plus 20 plus 5. Why could I do that? Talk to your neighbor and say why. Because a lot of people don't know.
You can break it up into all ones. 100 would be 20, and then 20 in there, so 25 would be 4, and then 5 times 5 is 1. 5 divided by 5 is 1, so, and you get 25.
A lot of people were unsure of why I could break it up into 100 plus 20 plus 5. Why can I? Are you ready to tell me now? Haley?
Because it will all add up to be the hundreds.
Right, and is 100 a multiple of 5? Is 20 a multiple of 5? Is 5 a multiple of 5? So I can break it up that way. But I might not break it up into 96 and things that don't add up to, that are not multiples of 5. Okay, so you got to break it up so that they're multiples of 5. Okay? I'm going to erase this because it's going to make it easier if I do that. Okay, so let's try it. Why did I get this? Sorry. I don't know why that came up. Let's try dividing. Let's do another one. This is what we're going to do this problem. The baker has 492 donuts to pack. Each box holds 4 donuts. How many boxes will the baker need? Can you set that problem up on your Smart Pal, please? 492 donuts. Each box holds 4 donuts. How many boxes will the baker need? I'm going to bring my easel over here because I'm having a little trouble with the Smart board today. So we can know how to set it up, right? 492 divided by 4. What does 492 represent? Because it's really important in these problems to know what these numbers represent. What does 492 represent? Baseballs? Pennies? What does 492 represent? Desks? Are we all with me? What does 492 represent? Dominic?
It represents the donuts.
Donuts. What does 4 represent? You need to know this, because what's the point of solving a problem if we don't know why we're solving it? What does 4 represent? Brooke?
Each box holds 4 donuts.
How many donuts each box will hold? So what are we looking for? Look at the problem. What are we looking for? What are we looking for? Shane?
How many boxes will the baker need?
How many boxes is this baker going to need? Okay, so we know how many 4s are in 492. You need to think, how many 4s are in 492? Now I'm going to give you a little guide on the side, because this really, really helps me when I'm solving these problems. We need a lot of boxes. And if we started taking one box at a time, it would take us a long time to figure out how many boxes we need. Okay? So as a little guide on the side, I'm going to think of multiples of 4, because I need multiples of the divisor, right? And I'm going to start with some big multiples. Over on the side, watch what I'm going to do, and you might want to do this too. 100 times 4 equals 400. Is 400 a multiple of 4? I just proved that it is, right? I just proved that it is, because we need to take away multiples of 4. 10 times 4 equals 40. Is 40 a multiple of 4? Yes. Why? I just proved it, because we know what multiples are. 5 times 4 equals 20. And I always like to do 2 times 4 equals 8. Okay? Does that make sense? That's a little guide on the side. Okay? So what I want you to do is work with your partner right now, and we'll kind of do this together, and see if you can figure out what the first, if you're thinking, I need to know how many 4s are in 492, what do you need to do first? We don't know? We're not sure? Tell me what I should do first. How about that? You tell me. What should I do first? I need to make boxes. This baker needs to make boxes. How many boxes could he make that we know that he can make, that we're sure that he can make, because he's got enough. He's got enough donuts. Think about multiples of 4. This baker has enough donuts. How many boxes are we certain that he can make to start with? We don't have to do it all at once, because remember, we're finding multiples. We're doing parts of the product. We don't have to find the product all at once. So what do you think, Mateo?
Well, the baker could already make 400 boxes.
He can make 400 boxes?
No, he could.
You sure he can make 400 boxes?
No.
How many boxes could he make?
100.
100 boxes. Do you see what happened? You were thinking that was the multiple. You want 100. So if he makes 100 boxes, is he good?
Yes.
He'll use up 400 donuts, won't he? And what will he have left? Copy along with me. Do this with me. What will he have left? 92. Good? Are we all there? Okay. Oh, you already figured it out. Okay, could he make another 100 boxes? No.
Oh.
Right? He doesn't have enough left. How many boxes could he make now?
40. 10.
What do you think? How many boxes can he make now? Lorenzo?
10.
Can he make 10 boxes? Okay, if he makes 10 boxes, how many donuts will he use?
I'll use 40.
40. And what will he have left, Lorenzo? He'll have 52. Is everybody good with that? Okay, let's keep going. Are we finished? We still have 52 donuts lying around. How many boxes can we make now? How many boxes can we make now? You got 52 donuts left. You just made 10 boxes and used up 40. Just made 10 boxes and used up 40. You have 52 donuts left. So I'm thinking, is anybody thinking the way I'm thinking?
Probably not.
Anybody? Probably not. You're hilarious. Jordan, what do you think?
10.
10 more boxes? Okay, I'm thinking, thank you, Jordan, you were thinking like me. So I'm thinking 10 more boxes, and we'll use up 40 more donuts. Am I good, Jordan? And what will I have left, Jordan?
12.
I'll have 12 donuts left. Okay, I'm gonna take those home, right? No. We need to make more boxes. How many more boxes can we make? Because don't forget, how many 4s now? How many 4s are in 12? I see those hands going way, way up. So happy to see that. Francesca?
3.
3. Why did you say 3?
3 times 4 equals 12.
3 times 4 equals 12. So I'm going to take 12 donuts away, and guess what? I'm done. Right? Sure? No. What do I have to do? What do I have to do? Am I done? Yes, I'm done dividing up my donuts. I'm putting my donuts into boxes, but I know how many boxes yet? No, what do I need to do? Megan.
You have to add up all the 100, 10, 10, and 30.
Right, which would give me
123.
123. How do you feel about that?
Awesome.
Great, I feel great about that too. So we have 123 boxes. Okay, one more and then you're gonna go on your own. You ready? Let's do this a little more quickly. My smartboard is not being kind to me today. Oh, roller coasters. How many of you guys like to ride roller coasters? Not me, I don't like to ride roller coasters. I think they're awful. I'm afraid of them. So roller coaster holds 6 passengers, right? We good with that? It's a small roller coaster. And there are 354 people in line to ride. How many times will the roller coaster need to run so that all of the people get a ride? Please, all I want you to do right now is set the problem up on your Smart Pal. What are we trying to solve? So that we can solve it using partial quotients, and then I can even show you the other. Do we have it set up like this? 354 divided by 6. Now you got to think quick now. 354 represents what? Not basketballs, but what? 354 represents what? Kaya? People. 6 represents what? Lucas?
The pack 6 seats there.
6 seats in each ride. And what are we looking for? Mia? Mia?
How many times will the roller coaster need to run so that all the people get to ride?
Okay. So we have to think, how many 6s are there in 354? There's more than 1. There's probably more than 10. Are there 100?
No.
No, so we got to drop it down a little bit. There's not 100 6s. Are there, let's think multiples of 6, okay? Now let's think, are there 20 6s? What's 20 times 6?
20.
Can we go higher?
Yeah.
Because we want to be efficient, right? How about 30? Lucas said, how about 30? Can we try 30? Who wants to go higher than 30? Anybody want to go higher? What do you think, Haley? Ruby? Sorry?
Maybe 40.
40 6s? I think we might be able to go a little bit higher with this one. What do you think, Mateo?
300?
300 6s?
Oh no, no.
You're on the right track. What times 6 is going to get you 300?
5. No.
Keep going. You're on the right track.
10.
You had the 5. 5 what? 5 10s, right?
Yeah.
What's 5 10s?
50.
50. So 6 times 50
50.
is going to get you,
350. No.
help him out. Phone a friend. Who's going to help him out? Dominic?
300.
300, okay? So, we all hearing this? Can we do 50 rides? Yes?
Yes.
So 50 times 6 is 300. And what are we left with? Copy along with me. Copy along with me. 54. Okay. Now, that should kind of jump out at you. We need to subtract multiples of 6. Okay, this is a multiple of 6, okay? But what times 6 is going to get you 54? Anybody know that one? This is where knowing your facts really comes in handy. Comes in awfully handy, doesn't it? Lorenza, what do you think? 9. 6 times 9 is 54. And we are done, right?
No.
One more step. Kobe?
You have to add 59.
And you get 59. And I just want to draw this in the model for you, because some of you might think, I want to do it this way. I want to break up 354 like this. I'm going to do 300, and I'm going to do 54. I don't want to do 300 plus 50 plus 4, because guess what? 50 is not a multiple of 6. 4 is not a multiple of 6, okay? So I'm going to do 354. And I'm going to divide by 6. So 300 divided by 6, or 6 times what is 300? And I can put a 50. There's part of my quotient. And 6 times what is 54? And I can put a 9. It looks just like the partial products, doesn't it? So either way works for you. Okay, now you're ready to work with a partner. So here's what you're going to do. You're going to erase your board. And you're going to solve this problem. You and your partner. Go like this with your elbow. That's your partner. Now, Kobe, you guys can, the three of you can work together. The three of you can work together. Whoever's sitting next to you is going to be your partner. And you're going to solve this problem using partial products, and you can use the rectangular model if you'd like to. But show all of your work and be prepared to share, because I want to see the different ways that we get a solution to this. Okay? Go ahead. You can begin.
Okay, so we're gonna do 3
So we're going to do 10 equals 200.
Oh yeah. How did 3 equal to 200?
Right, so
3 times 1 equals 20.
no, I think 20.
You're thinking how many 3's are in 225, right? You're thinking how many 3's are in 225. So start thinking big. Is that there's a lot of 3's in 225. Okay? Remember, you're thinking how many 3's are in 225. And 225 is a pretty big number. There's probably a lot of 3's. No, it's not a multiple of 3, but you can subtract multiples of 3 from 225. So think how many, are there at least 10 3's in 225? Start there. Okay? If that's kind of small, it's going to take you a little while, but start there.
Minus 10.
Interesting. I like what you
can't
guys
do
did.
that.
Make sure you keep that, because I want you to be able to share that. Now I'm thinking this. Are there at least 100 3's in 225? No. So you might want to change that up a little bit.
So it's going to be 80. No.
You don't have to do it all at once. It could be different. And that's what I kind of, you can leave that. Do me a favor and keep that 40 there. What's 40 times 3? 120? Yes. So subtract 120. Keep this method, because I want you to show that, okay? Keep doing that.
I don't like this method.
Remainder?
I don't think that's right.
I don't think there's a remainder. Okay. 225. Is that a 4? Okay, so 40. Can't. This is like erasing. It's 120, so 5. 105. Okay, well, there's not another 40. Are there another 10? Or 20? What's 20 times 3? 60? Okay.
That's not a 7s.
Keep going. When you have your solutions, please do not erase, because I do want some people to share. I want to get different solutions up here.
did it a different way than me.
And actually, I'm going to ask you to come up and show your solution. Okay, I'm going to at least 2 solutions and possibly a third. Did everybody find a solution? You're trying to do it all in one.
I got it.
I'm so happy that you got it. You did it all in one. You did it by a little trial and error, which is really interesting. So I want you to talk through that with us. But I also want some people to show us using the algorithm or using the method, the partial products method, partial quotients method. Sorry. Okay. So Lorenzo, come on up here. Do you need to bring your Smart Pal if you can, if you want to? Here's what you have to do, Lorenzo. Look at your classmates. You need to be able to talk to them and tell them what you're doing. Okay? I'll repeat what you're doing. Okay? So what are you going to do first, Lorenzo?
I'm going.
You want to just tell me and then I'll write it? How about you tell me and I'll write it?
Okay.
Stand here with me.
Alright. So I did 210, which is, so I put the 70 here
Why did you put the 70 here?
because 70 times 3 is 210.
270. Why don't you sit at your desk? It'll be easier.
Okay.
So you thought there were at least 73s in 225. So he put a 70 here because he's recording, right? Just like we did yesterday when we did the repeated subtraction. You have to keep a record of what you're taking away, okay? So 70 times 3 is 210.
And I subtracted it.
And you were left with
15.
15. So then you thought how many 3s are in 15?
5.
5. So
I did 15 minus 15.
why'd you do 15? Because you thought 5 times 3 is 15, right?
Yeah.
You subtracted 15 and you were left with 0. And your answer was?
75.
75. Okay, I'm going to get to you. I promise, Sebastian. Did anybody do it with more steps? This is the least amount of steps. Actually, we can do it in 1 step if you really want to. But did anybody do it with more steps than this? And I saw it over... Did you guys finish it? Yes, I saw it over here. Okay, you ready? Kaya, you want to tell me what you did?
Sure. First, I subtracted 120
You subtracted 120. Why?
because 40 times 3 equals 120.
40 times 3. So you thought there are 43s in 225 at least, right? And you got 105, right?
Yes. And then I did subtracted it by 60, and because 20 times 3 equals 60.
Okay, so then you thought, can I just make the class understand what you're saying? So then you thought, well, there's 23s, at least 23s in 105. So 20 times 3 is 60. And when I subtract 60 from 105, I get 45. Okay?
And then I did 45 minus 30, so I put a 10, and because...
You put a 10 here. Why'd you put a 10 here?
Because 30 times 10 equals 30.
Right, so you took 10 threes, and that's 30. And then what do you have left?
15.
15. And then when you thought...
And then I subtracted 15, and I put a 5 right there because...
You put a 5 here because you're going to take 5 threes away, and now you're left with nothing, right? And so what's your quotient? 40?
75.
75. Same answer, different steps. So there's different ways to do this, and I'm sure that some of you guys did some trial and error here, and they just kind of started thinking, what times 3 equals 225, and they just kind of just kept doing it until they got their answer.
We experimented.
You experimented a little bit. I'd like to see you actually think through getting multiples of the divisor out so that you're not making yourself nutty like that.
So
Think through the process, okay? And let me just draw this in our model. Nobody did this?
yeah, we did.
You did? Oh, good. Can you tell me what you did?
So we split the box in half,
Yeah.
and we did, the 3 would go on that side,
Yeah.
Then we did 201 box.
201?
No, 200 in one box.
200. 3 times something equals 200?
No. Oh, no, 210.
I thought so. I thought I saw that. 210 here. And then what was left over
and
here?
then 25.
Are you sure?
No, 15. Oh my gosh.
210 and 15. What do you notice? If you put these together, what are they? 225. And why did why'd you break it up this way? 210 and 15.
Because,
Does 3 times something equal 210?
yes,
3 times what equals 210?
70.
70. Does 3 times something equal 15?
Yes,
Yes. 3 times what equals 15?
5.
5. There's your quotient, okay? So there's your rectangular model. Okay, so now that you've tried to solve it with me, you've tried to solve it with a partner, I'm gonna see if you can do it on your own. And you know what, in interest of time, let's just see if we can just do one of these. I'm gonna give you these papers. You can erase. Just show me that you can do one of them. You can pick either one, it doesn't matter. You can use this way, or you can break it up this way. And try to do this on your own so I can see what you know, okay? I just want to see what you know. You can use your Smart Pals to do your work, but just copy the work onto the paper so I have it, please. Okay? You're just doing the front. Choose one or the other to solve, okay? You have to do it on your own. That's his. This is yours. You can use your Smart Pals as like, a workspace if you'd like.
Can we do this page?
Nope. That's for later, sweetie. Okay, did you just do this in your head or something?
Yeah. I thought 4 times 100 is 400, and then I know 4 times 7 is 28.
Wow. Very interesting.
And then this would be 12 times 12 is 720. Yeah, 6 times 100.
Do this the other way for me before you do that, okay? Break it apart, okay? Because I see 720. But then what's left?
18.
Okay? So you know what? What I'm seeing that you're doing, you're just such a smart thinker. So do 720, do 18, and show me the 2 parts there, okay? See what I mean? Just let me know that you understand it. Show me that you can do one of them. Okay. Because then I want to take some, work together in some groups. And you're going to share this thinking later on when we do our little debrief later on, okay? Okay, so here's what I'm thinking. I need to get my notes. Let's see. Here's what I'm thinking, what I'd like to do. Based on what I see, let's go with do our games that we practiced. I want you to leave these papers here. Put your name at the top because there's a place on the end. Some of you are going to do that second page, which is a kind of a story problem that you're going to solve, and some of you are going to come with me. So let's work it this way. Remember what we have to do when we move around. So just stay where you are for a minute, okay? With me at the back table, I want Shane, Sebastian, Victoria. Victoria and Faith, come with me for now. I might release you, but just come with me for now. So go to the back table, bring a Smart Pal and an eraser and a marker. And then, let me see, over here, can I have Megan, Francesca, Dominic, and Ryan? You're gonna play dividend rolls. And Taylor, you're gonna come back to this table. You guys can stay right where you are. And you do teams for divide all 5. You can leave these. Before you start, if you're playing a game, before you start, can you do the second problem and then check it with your table group, okay? Do the second problem on the back, the second page, and check it with your table group before you start. You guys can do dividend rolls. So you're gonna do this. You need these. You need these. And you need these. That's fine if you already have them. You're going to do divide all 5. Make sure you check with your table group. Okay?
I might.
You're going to do divide all 5. Do that other problem and check your answers together of that second problem, that second page. You can play divide all 5. Yeah. Do it on your own, but then peer check it, please. Do that second page on your own and then peer check it, please. This page. And then you guys can play in teams. You can play divide all 5, okay? You're welcome. Now, you guys might, there's a seat right here, honey. Oh, it's too close to the, okay. That's fine. I just want to make sure that we understand the process, and I know that you guys had some really good thoughts. So you guys can go on and finish those, check together that second page, that page with about the baseball cards. Do it first, check it with each other, and then you can go on and play the games in teams, 2 and 2.
In our thing, it was black and white.
I know, because I didn't make that many color copies. Okay, here's what I wanted to do with you. Where's my little Smart Pal? Can you grab me a Smart Pal? Another Smart Pal, please.
Mine's broken.
Okay. I noticed. You guys actually had the answer, but I wanted to make sure that they were. Yes, you did. Okay. And I'm going to go over these together. Let's just do these together.
Wait, I need to
okay?
see something.
These share and show ones together. So it's 428 divided by 4. And I want to ask you some really important questions before we start. Sebastian, okay? I want to ask you some really important questions. When you're doing this kind of problem, 428 divided by 4, what are we really looking for? Well, we are, but what are we really looking for? We're really looking for how many 4s are there in 428. Okay, I know that you already know, okay? But you did some interesting things with trial and error, which is really great. But I want you to be able to move to the next level, which is doing the standard algorithm. We won't be able to do that if we don't learn these steps, okay? So, if I want to know how many 4s are in 428, I can sit there and say, do all these things on the side, but I really want to know, I really want to have some sort of method for doing it. So we need to take away multiples of this divisor. Why did you write 100 there? Because I saw it. Why did you write 4?
What's our total? And also, the 28 part was 7 because I knew 4.
Okay, so you just jumped a step ahead of me. Okay, so you thought, right? You thought 100. If I can get 100 4s out of 428. So let me take away 100 4s. Okay? Oh, I just saw an aha coming out of you, right? So if I take away 100 4s, that would be 400, right? And I would be left with 28.
That's 28 minus 7 equals
28 minus 7. Why are we subtracting 7?
28 minus 28.
But why are we taking away 28? Because are we thinking now that we have 28, and I'm going to show you something. I'm going to show you something with these because I want to make this real for you, okay? Okay? Because now, since we have these 428 oranges, right? We want to put them in boxes of 4. we made 100 boxes, and we used up 400 of our oranges. And now we have 28 oranges left. So how many boxes can we make now? And I want to show you something. So 1, 2, 3, 4, 5, 6. Count out 28 for me because I want to talk. If you check your answers on the back of that second problem, that story problem about the baseball cards, then you're ready to play Divide All 5 or what's that, dividend rolls?
Not enough. There's only 22.
22,
You need 6 more.
23, 24, 25, 26, 27, 28, okay? So I want to know how many times can I take 4 away, right? Well, let's start doing it. 1,
Here, let me do it.
2, watching Sebastian? 3,
I like to
4. Okay, I've taken 4 4s away, and I can actually record that. I can start by just recording that. If I take 4 4s away, I took away 16, didn't I? And then I'm left with 12, right? Am I left with 12? Let's see if I am. 1, 2. Yes, I'm left with 12, right? Am I left with 12? Sebastian, are you with me? I'm left with 12. So I took 4 4s away and I used 16. So I can take 3 4s away. I just want to show you why this is happening. And I'm going to use 12, right? 1, 2, 3. Took 3 4s away. And there's 7. So I took 7 groups of 4 away. I took 7 groups of 4 away, plus 100 groups of 4. So how many groups of 4 did I take away? Because it's not, I don't just want you to find the answer. I want you to understand what you're doing here. Now watch, look at my little piles. 1, 2, 3, 4, 5, 6, 7. 4 groups of 4 is 16. 3 groups of 4 is 12. I took them all away, and now I'm now left with nothing. First I took 100 groups of 4. 400, boom. But then I had 28, and look what I did. And I'm left with nothing, okay? I want you to show me that you can do this on your own, really on your own, okay? The actual method. So let's see. Or, oh, I forgot to do this. 428 divided by 4. I can also do this. I can take 428, watch this. This is what I think you'll like. 428.
That's what I did.
Okay? I can break it up like that, because it's kind of the same thing I did. And I'm thinking, okay, 4 times what equals 400? Well, 100. 4 times what equals 28? 7. 107.
Fun.
That is fun, isn't it? So I think for you guys, you might even like this part this way better. Why don't you look at the second problem then? Oh, that's kind of a hard. Can I change this problem a little bit? I'm going to change this too. Let me do it by 3.
I wasn't very good in that 6, but I found it out. Okay, so it's 95.
96 divided by 3.
Oh my god, 41 divided by 1 pile.
The area.
721 divided by 1. 7.
And you can see the
96 divided by
15.
Yes. Because 4 times 12
Here.
6.
I don't give up. Like, so no.
Okay. I could. I can't even run the whole way down. You could too if you went the whole way across. I still don't want to say anything. 1. Well, you're
I think you like that way.
You're subtracting. You were good. Look. You were good. You do 11 and then you get 0. 378. 9 you do 11 and you get 9 times 2 equals 18. 118. That's 180. So that one.
I'm gonna say
63. Oh, you could do 7, and that's 63. And you're done.
And then
And then just add those together.
This. But 9 times 2 is 20. 2 plus 2 is 4. 85, right? Then you subtract
7,
that.
8, 9, 10, 11, 12.
7 minus 8 cannot do that, so you do that.
Okay, I'd like you to clean up your games now and come back to your desks. Thank you. When you clean up your games, put everything in the bags and bring me both parts. You only brought me one part. Where's the bag? There you go.
We didn't even get to play.
I'm sorry, what happened? Were you discussing the problem?
No, me and Ben didn't finish in time.
You didn't finish in time?
Well,
I'm
I
sorry.
finished, but Ben didn't finish.
Ben, are you okay? We'll talk tomorrow if there's something that... Oh, I'm sorry.
Yeah, we didn't even get chips.
Oh, you could have asked me. I'm sorry about that. Well, you know what? I promise later on I'll let you give you a chance to play. Okay? I'm gonna give you like 30 seconds to get back to your spots. Oh, thank you. Okay, just a real quick debrief. I don't know why this came up on here. Okay, first of all, I know that some of you did the baseball card problem, and later on, if you have the baseball card problem, could you make piles of the work that you did, put piles in the center of your table so I can come around and grab those from you? So I can see how you did with that. And if you did the baseball problem, I hope you did, in fact, check it with your group members. Just make a pile in the center of your table of your work. I just want to talk real quickly. I don't know why this is not doing this. I want you to talk to your partners. You get one more chance to talk to your partners or talk to your table group members. And then we're going to share this out. What's one thing you liked about the method you learned today? And some people over here that are working with me really discovered that they like the area model. Okay? So what's one thing that you liked about the method you learned today, whether it be the area model or the traditional partial products? Both are the partial products, but we're just sort of showing them in a different way. And if you worked in a center, sorry if you didn't get to your game, explain how it helped you practice division. So take a minute, talk to your group, formulate an answer to come together because I'm going to ask you to share it out with me, okay?
We tried the game before, but we didn't.
that's a lot easier.
It is a lot easier than
Then all the work down.
it's a lot easier. Yeah, it's a lot easier.
It's a lot easier.
Yeah, you don't have to like what is it? Oh my god, I don't know this. Yeah, so you're like, what equals that? Oh, yeah. 4 plus 4 equals 8. Yeah, like, it's in that we're like,
You're doing more problems than you can just do with 2 numbers.
I heard some really good things, and I'd like for some people to share because I was listening in on a couple of groups. Faith wants to share because I heard what Faith was saying, and I'm going to have Faith share. Faith, the answer that I heard you answering was the method that you learned today. So could you share with the whole group? I know you shared with your group. Could you share with the whole group what you liked about the method you learned today?
I like the area model because it's more of multiplication, which I already know, so I can just use the answers of multiplication to get to division and then add it up.
Yeah, she likes the area model because it reminds her a lot of what she did with multiplication. And I heard you say the distributive property. And so that was more familiar to her, and it really helped her find those. She found the missing factors, which in fact are your quotients. That's what she liked. Okay. I heard something happening over here talking about practicing how it helped him practice division. Do you guys want to share what you were saying?
Okay.
Yes.
Our game helped me practice division because we had to find a multiple to whatever we rolled on the dice. So if you got a 5, you had to pick something that that 5 could go into.
That was a multiple of 5. And when you're doing these methods, you have to be able to look for multiples of the divisor, don't you? So helping you practice to find multiples is going to help you practice this method. Haley, would you like to share what your group talked about?
Yeah, our group had all like the partial products way, not the area model, but
Yeah, you liked the partial products that wasn't the area model.
Yeah.
Partial. They're both partial products, by the way, but there are different ways to show it, different ways to record it.
we liked the first one because it's more of division.
You felt more like division to
Yeah.
you? Did anybody mention that they liked that there's different ways to solve it? Different ways to get the answer? Do you notice how we have the same answer here, but 2 different ways to get it? Does that help you? Does that make you feel a little bit more comfortable with it? Does another group want to share? One more share before we end? And we're really quiet. Megan?
Well, I did partial quotients because if you were doing like 887 divided by 7, 28 is a multiple of 7. It's times 4.
Oh.
And 40 times 7 equals 280. So subtract that, it equals 7, and then 7 times 1 equals 7.
You know, I need to just jump on that for 1 minute because this is perfect for where you're going to go next time, okay? This is where we're going to go next with our math, with our division. 287 divided by 7. This is what she said. This is really easy because I know that 7 times 40 is 280, right? And then I'm left with 7, and 7 times 1
Equals 7.
is 7. Oops, 0, sorry. So that's 41. And guess what? You're going to start doing this. You're going to start looking at the 228 tens. That's what you're going to start doing with your next step with division. So you've actually made that step in your head already, so that's really, really great. Okay? So that's like a little preview to what you're going to be doing. Okay, boys and girls, I hope you had a good day.